Hello guys and welcome to our new video. Today we will discuss Notes of Force and Laws of Motion, Chapter 9 Physics. Let's forward towards the notes. Force and its effects. Do you know what is a force? The correct definition of force is a push or pull on an object is called force. What are the effects of the force? A force can move a stationary body. A force can stop a moving body. A force can change the speed of moving body. A force can change the direction of a moving body. And a force can change the shape and size of a body also. Then what are balanced and unbalanced force? There are two types of forces, balanced force and unbalanced force. First we will discuss about the balanced force. If the resultant of all the forces acting on a body is zero, then forces are called balanced forces. The highlighted point of the balanced force is if a number of balanced force act on a stationary body, the body continues to remain in its stationary position. Similarly, if a number of balanced forces act on a body in uniform motion, the body continues to be in the state of uniform motion. Though balanced forces cannot produce motion in a stationary body or stop moving body, they can however change the shape of a body. Now we will discuss what is an unbalanced force. If the resultant of all the forces acting on a body is not zero, the force is known as unbalanced force. Unbalanced force can move a stationary body or they can stop a moving body. To move a stationary body, we have to push it with a force greater than the opposing force of friction. If there are no unbalanced force of friction and no air resistance, a moving body will go on moving forever. Now we'll discuss what is the Newton's first law of motion. As you know that there are three Newton's laws of motion. First we will discuss Newton's first law of motion. Statement: a body at rest will remain at rest and a body in motion will continue in motion in a straight line with the uniform speed unless it is compelled by an external force to change its states of rest or of uniform motion. The first law of motion is also known as inertia. Then what is inertia? This question might be coming in your mind. Inertia is that property of a body due to which it resists to change in its state of rest or of uniform motion. Then what is the reason behind it? The tendency of undisturbed object to stay at rest or to keep moving with the same velocity is called inertia, which is exactly same as the first law of motion. Mass is also a measure of the inertia of a body. Then what are the types of inertia? Inertia may be of three types. Inertia of rest. Ability of an object to resist a change in its state of rest is called inertia of rest. In other words, an object cannot change its state of rest on its own. Then inertia of motion. The property of an object to resist a change in its state of uniform motion is called inertia of motion. Then inertia of direction. The property of an object to resist any change in its direction of motion is called inertia of direction. Then what is momentum? The force required to stop a body is also directly proportional to its velocity. Thus, the quantity of motion in a body depends on mass and velocity of the body. This gives us another term known as momentum. The momentum of a body can be defined as the product of its mass and velocity. So we can write momentum equal to mass into velocity, or P equal to mv, where P equal to momentum, m equal to mass of the body, v equal to velocity of the body. The SI unit of momentum is kilogram meter per second or kg into mass per second or kg into meter into second to the power minus 1. If a body is at rest, its velocity is 0 and hence its momentum is also 0 since momentum is the product of its mass and velocity. Momentum is a vector quantity. Now we'll solve a simple problem about the momentum. What is the momentum of a man of mass 75 kg when he walks with a uniform velocity of 2 meter per second? The solution of this question is, we know that momentum equal to mass into velocity, or imply that m into v, where mass m equal to 75 kg, velocity v equal to 2 meter per second. Putting these values in the above formula, we get momentum equal to 75 into 2 kilogram into meter per second equal to 150 kg into meter per second. Like that, you can solve many other sample problems about momentum. Now we will discuss what is Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Force directly proportional to the change in momentum by time taken. So, F directly proportional to mu minus mv by t, or F directly proportional to m whole into v minus u by t, or F directly proportional to m into a, as we know that a equal to v minus u by t, which gives us the Newton's second law of motion, force equal to mass into acceleration. So this was about our whole video. Don't worry guys, part 2 will be coming soon. In part 2, we will discuss the topics like derivation of Newton's second law of motion, application of Newton's law of motion, explanations of Newton's first law of motion from Newton's second law of motion, Newton's third law of motion, conservation of momentum, and mathematical derivation of conservation of momentum. Till then, goodbye. Wait for the next video and keep watching. Let's meet in the next video.